Hi, this video is going to be a processing video of some data I captured of Messier 33, where I have about 30 hours of total integration time taken with an f6 scope and a 294mm Pro camera. About a week and a half ago, I published a video about a no AI challenge where I'm trying to get the community to process this data without using artificial intelligence tools like BlurX, Star Exterminator, StarNet++, and other sort of neural network tools. And I thought I would make this video to show how I processed it without any neural networks. And I think, as you'll see, if you've got a lot of data and good signal to noise ratio, sometimes you might not need to rely on the AI tools as much. And I think you can get a pretty decent image. Welcome to Deep Sky Detail. So let's go ahead and I'll bring up Siril. Here we go. I've got Siril open, and this is the luminance data for Messier 33. This is just an auto stretch applied, and I think you can see like it looks, I think, pretty decent. I think we've got some good signal here. We're going to be applying a deconvolution to the L layer. We're going to subtract the red layer from the HA layer luminance data and into the RGB data separately in order to bring out all of the HA emission nebula that are in Messier 33. Then we'll be taking sort of the luminance layer that we create as well as the RGB data in Gimp and combining it to make a color image. And before we do that, we'll apply maybe some high pass filters to it to bring out some of the detail in the spiral arm. We're going to keep all of the data so far linear. This is what the linear image looks like. So I'm going to go ahead and apply the auto stretch again. I'm going to go to image processing and deconvolution. And what deconvolution is going to do is going to help control the stars a bit. It's a really subtle effect, but I think it's a good one. I'm going to change PSF source from line deconvolution to PSF from stars. I want also to make it a symmetrical PSF because I think that's the best with my data. If we scroll around the image a little bit, we can see that some of the corner stars, there's maybe some chromatic aberration a little bit going on, a little bit of field curvature in the corners. For this tutorial, I'm just going to do one simple PSF. Based on some trial and error before, what we want to do is maybe do about 20 iterations. And we can change gradient descent step size to about maybe 0.0005. Then I'm going to go ahead and click apply. We're going to wait for the deconvolution. Now that the deconvolution is done, we can go and undo this. And we can see that the stars are a little bit more tight, which is what we want. We could even try this one more time, maybe like 10, bring the gradient descent size back down to 0.003, which is the default, and click apply again and see if we can get a little bit tighter stars. Yeah, there we go. The main thing is we don't want there to be ringing around the stars. That makes it look bad. So we just kind of go around, make sure there is no dark halos. If we zoom out, I think everything looks good. The main thing here is to, again, make sure there's no ringing and make sure things still look not overly sharpened. I'm going to go ahead and save this as a 32-bit TIFF file, and I will probably call this deconvolved. I'm going to save this as a 32-bit floating point TIFF file so that we make sure we're maintaining all of the data that is in the image. I'm going to go ahead and save that. It's warning me that the viewer mode is not linear. That's fine. We haven't stretched anything yet, so we're going to save anyway. Okay, now that we've got our L data, what we want to do is go into pixel math and load all of our images in here. I've already got the R, the HA, the G, and the B data loaded into pixel math. What I need to do now is load in that deconvolved image that we just did as the L. So I'm going to go ahead and open that up. Because everything was stacked in Siril, Siril knows that this is the L. I used the luminance filter with it, so it already assigns a variable to it called L. And what we want to do is put in this equation here. There's a great tutorial by Stefan's Astra on how to incorporate HA data into your RGB and L data. I'll link that video in the description, and this is what I did. Basically, what this is doing is taking the HA filter data, it's subtracting some of the R data from it in order to bring out the nebulae in the image. And there's this parameter Q that we're adding to it. All of the formulas will be linked in the pinned comment, but this parameter Q determines subtraction from the R channel is from the HA channel. So if we go ahead and apply this, let's say Q is something very small, like 0.001, most of it's going to be just the HA data. What we want to do is subtract the R data from it because the R data also includes the HA data. And so if we just add the HA data as the R channel in our final processed image, they're going to look a little bit weird, and we're not going to be able to make those nebulae pop as much as we want to. The parameter that I chose for this is about 0.36. Every image is a little bit different, and what you want to see is all of the nebulae that we know are sort of nebulae want to pop out, as well as make sure that none of the galaxy is subtracted too much. Also, I think an important thing is to make sure that most of the stars don't have any HA data in it, so that the stars are black, mostly black, and that's fine. What we want to do now then is save this image in a linear state, again, as a new file. I'm just going to call this the HAR file. Again, save it as a 32-bit FITS file. We're okay with it being in linear mode. Now combine that HAR data with the green and the blue filters to make sort of an RGB image. That includes this HA stuff. Again, we're going back into pixel math. What we want to do is uncheck this use single RGBK expression. We also want to load in that image that we just created, this HHR image, and I'll just name it HHR. Okay, so each of these variables is an image, and now we replace these expressions. We want to change this Q parameter again, and this time we're going to increase it. I found that 6 works kind of okay, so let's try 6, and we'll click apply. And you'll see that everything is fairly green. That's okay. We can do a background neutralization to make it look more natural. So we go to image processing, color calibration, and then color calibration. We select an area of the background. We click on use current selection and then background neutralization. And then we get a nice sort of color image here. Now, if that's a little bit too pink for you, we can go back into pixel math and we can maybe lower this to 4, click apply. Again, we're going to have to do a background neutralization. But the thing is, you just keep kind of iteratively doing this until you get the colors that you want. And this looks okay. The next step, I'm going to do a background extraction. So I'm going to do image processing background extraction, make sure RBF is clicked. RBF for this challenge, it should be fine. So I'm just going to make some points around the image. I'm going to turn the smoothing all the way up just for the initial background extraction. I'm going to add a dither. I'm going to compute the background, and you can see it kind of gets rid of a lot of the gradients that were in the image, which is nice. To where double check ourselves, we can move this slider down and compute the background again and see what's going on. Yeah, I think that's fine. So we'll click apply. We're good. And then I think I want to remove the green noise. I'm just going to click apply, and there we go. Now a lot of this color corrections we're going to be doing in Gimp anyway. But what we can do is go to image processing, color calibration, photometric color calibration, type in M33. We're going to find it. Now my data were taken with a ASI 294mm Pro camera in bin 2 mode. And so the FITS file says it's in bin 2 mode. It also says the pixel size is 4.63, which is the pixel size in bin 2 mode. And Siril takes that for some reason and multiplies the 2 by the 4.63 to get 9.26. Really, the pixel size is 4.63. Focal length is 480. We just click OK, and it should do the photometric calibration pretty quickly. It did. And while we're with this image, we might as well stretch the image and save it as a stretched image. So let's go ahead and go to image processing. And the first thing I'm going to do is the arc sign transformation. I'm going to bring the stretch factor up quite a bit, and the black point up until we start to see the galaxy. And we just want to do sort of an initial stretch just so we can keep the color in everything. And make sure we're not bringing the black point up too much where we're clipping the image. We can go and click apply, and now we can do the generalized hyperbolic stretch transformation. What I'm going to go ahead and do is click on the side of this histogram, the left side of this histogram, to set the symmetry point. You can see the symmetry point changed here. And we're going to bring the local stretch intensity slider up. as well as the stretch factor up, we can start to see the galaxy 3 hours of RGB data plus the HA data that we have in here. So the galaxy might not stand out as much from the background as the L data does because we have 22 hours of data there. I'm going to go ahead and click apply. I think that's good. I'm going to bring the black point down so we can darken up the background. We can see kind of more what's going on. We click apply and then generalize hyperbolic stretch transform again. And then we're going to do logarithmic scale. Now these little bumps here and the red and the blue channels, those are not anything that we need to pay much attention to because those are just from the stacking artifacts. We're not cropping anything yet. We're not cropping out the stacking artifacts because we will crop in Gimp. So we want to keep everything kind of uncropped as much as possible in order to align things in Gimp as easily as possible. So basically what we want to do is we want to bring this line up, trying to take the line and bring it up a little bit. And we're going to stretch it. We also want to keep this line as straight as possible, ignoring these bumps. So I'm going to go ahead and find a symmetry point. So maybe we want to increase the contrast of the fainter areas of the halo around the galaxy. So I'm going to click that as the symmetry point. And I'm going to start to bring the stretch factor up a bit. And I think that looks okay for an initial stretch. We want to make sure that the stars aren't being blown out. So if I bring this back down, bring it back up, and the stars start to get blown out, that's kind of where you want to stop. We don't have to stretch the RGB data so much because the RGB data doesn't contain all the information that we're interested in. The L data does, the luminance data does. So we're going to click apply. Maybe we will do another linear stretch to make this darker. Linear stretch, I like the non-logarithmic scale because you can see where you're clipping better. I think it's okay to clip it a little bit, especially the R data. With the L data, try not to clip as much, just to make the background a little bit darker. And we can click apply and close. All right, so we've stretched it. I'm going to go ahead and say this is an RGB fits file. I'm going to call it RGB stretched.fit. And it's going to ask me to save it as a 32-bit floating point, which is what I want. And now we need to work on the L data. Go back to Pixel Math. We've got all of our variables in here. What we want to do now, click on use single RGBK expression again. And instead of R here, we want to put in L. And that's all we have to do. That's the only change. And for the Q, we can keep it about 4. We'll play around with it. But what we want to make sure is that the HA data, a little bit of the HA data is coming through in the luminance channel. Okay, Siril crashed on me. I don't know what happened, but it crashed on me. We're going to go ahead and put in our equation to create the new luminance data, which is based on the L data and this HHR data that we created previously. Our Q, I think we're going to leave it as 4. We're going to check this and we're going to go ahead and click apply and look at the image and see what happens. So let's go ahead and put an auto stretch on. What this Q parameter is doing, similar to when we subtracted the R from the HA, is this determining how much of the image is from our L filter versus how much of the image is this new HAR luminance layer that we created. 4 is okay. We turn this down to 0, and the whole image is just going to be the data from our L filter. Now, I generally prefer to keep as much of that as possible because we have the strongest signal in the L filter for this image. I don't want to have the image dominated by the HA and the R filters, so I'm only going to keep the Q as about like a 1 or a 1.1. What this does is it makes sure that that HA data is a little bit more prominent later on. So again, if we check here, I know that there's a nebula here in Messier 33. So if we go back from 0 to 1, you can see that the nebula, the structure of the nebula comes out just a little bit more. If we were going to make this like a 10, we would see all of the nebula here, all this nebulosity from it. We're sacrificing some of the luminance data. So I don't want to go that strong. I really only want to go to 1. Because in theory, the L filter should contain all of the data that the HA filter does. This is just helping make the nebulae pop a little bit more. All right, okay, so I think that's good. What we want to do now, again, is the generalized hyperbolic. So let's go to generalized hyperbolic stretch transformation. We can zoom in if we want to. Click on the left side of this histogram to set our initial symmetry point, and then turn our local stretch intensity slider up quite a bit and our starting to stretch factor up. we can start to see the galaxy come through, all the data coming through in the galaxy. We can start to stretch this. Again, we want to kind of zoom in into the stars, make sure that we're not making the stars bloated, which doesn't seem to be the case. We're just doing a light stretch initially to see what's going on. We click apply, and then we're going to zoom back into up to 1, and we're going to do a linear stretch again to bring this black point down so we can darken up the background and see what's happening a little bit better. Click apply here again. We're going to go back to generalized hyperbolic stretch transformation, do logarithmic scale. And again, we want to bring this line up without making things too wonky. So let's go ahead and find a symmetry point in a darker region of the galaxy. Click the eyedropper to set that as our symmetry point and start to stretch. As we do this, we can see that the edges of the histogram and the logarithmic scale are going up. So we might want to bring down this highlight protection point to control the brightness in those areas. Zooming out just a little bit just to see what's going on. Seems like a good stretch again. We can also apply a linear stretch. Again, this here is just the stacking artifacts. So we can try and maybe get rid of those so it's not as prominent. We click apply again, and then go back to generalized hyperbolic stretch transformation. Let's go ahead and try and make this line, this curve, go up some more. So let's go ahead and click here as our symmetry point and start to really stretch things. Now again, we're seeing a bump here in the highlights, which means that the stars are starting to get blown out. So let's go ahead and move this highlight protection point down a little bit. And that will help control the stars, I hope, a little bit better. Click apply. And now what this histogram is showing us, besides this bump, which again is, I think, stacking artifacts, is showing us where we need to increase the contrast. So we have a little bump here. I don't know if you can see it. So I'm going to go ahead and click here and set that as our symmetry point and start to stretch that area. As we do that, as this flattens out, you can see that the galaxy, which is what we want to bring out the detail of, is getting brighter. And we're getting some bumps here. So maybe we, again, try and bring this down a little bit, apply. And we have a bump here, right? So maybe we want to bring this down. So local stretch intensity, we can click here to set the symmetry point here. Take the local stretch intensity, move this down, and then start to stretch this back out. And there we've darkened the background. We've sort of improved the contrast. The thing that we're trying to control is this logarithmic histogram, right? We don't want there to be crazy bumps in it. So now that we've done that, we've started to straighten this out again. Let's go ahead and click on this part. Again, we're setting this as our symmetry point. We're going to stretch this again, just a tad. And there we go. We've got, I think, a nice image of Messier 33 where the background is separated from the actual galaxy itself. And there's like this faint halo around Messier 33 has been stretched fairly nicely. Now you can keep playing this as much as you want in order to make sure that the stars aren't quite as bloated or whatever. But generalized hyperbolic stretch is a very powerful tool, and it's an effective way of stretching your image without overly blowing out the stars and things like that. Maybe the stars here are a little bit blown out, so I can, again, move this down. I'm generally happy. So I'm going to go ahead and save this as a 32-bit TIFF file as my luminance layer. And I might make a note saying that it's the L and the HA combined. Go ahead and save that. And what we want to do now is bring this into Gimp. I'm on Gimp release candidate, Gimp 3.0 release candidate 2 at the time of this recording. It is a little bit buggy, but it does really well. I think it's a really powerful program, although it's not maybe quite as intuitive as Photoshop is. I'm going to go ahead and open the RGB image. If I open up the RGB stretched image first, then that makes sure that the project that Gimp is working on is in color. If I opened up the luminance layer first, that would make the project a monochrome image, and we'd have to go into image mode and change it from grayscale to RGB. So it's just another step. So now we can open as layers. So file, open as layer, this new luminance layer that we created. It's going to ask us what we want to do for undefined pixels, and that's fine. Because we didn't crop anything in Siril, the RGB and the luminance layer should be aligned. You can see that the stars and everything they're still aligned. I'm going to make the RGB image invisible for a second. We're going to be processing the luminance layer. What I think we want to do first is apply a high pass filter to the luminance layer. All images have different frequencies. There's high frequencies and low frequencies. And the high frequencies are where a lot of the detail are, and the low frequencies are where a lot of the sort of general information is. So general shapes, general color, general sort of brightness values. But we want to bring out more of the detail. So we want to apply a high pass filter to the luminance data in order to bring out more detail. But we want to do it in a controlled way, in a way that doesn't bloat the stars and doesn't mess things up. I'm going to Control-Shift-D to duplicate this luminance layer. And I'm going to go ahead and change this to high pass. Make sure that the high pass layer is selected. And we're going to go to Filters, Enhance, High Pass. Now a little dialog box is going to pop up, and we want to play with the contrast and standard deviation sliders until we get something we like. This is okay. It's not bad. We can see that the spiral arms are starting to pop a little bit. However, when we do this, the stars get really bloated. So let's go ahead and click OK and go to change the mode, the high pass mode, from normal to soft light. Now this is way too strong. It's darkened up the background. It's brightened up the stars. It has brightened up the galaxy quite a bit. We're going to change the opacity of this high pass filter, maybe to something like 20%. Additionally, we're going to right click on the layer and we're going to select add layer masks and make this black for full transparent. And so what this layer mask now is doing, it's hiding the high pass filter. And we have to paint in with white. So go to the paint tool, make sure white is selected, and paint in the parts of the galaxy we want to apply the high pass filter to. Increase the brush size, zoom in a little bit. I'm going to decrease the hardness and decrease the force. And just start painting in around the spiral arms where we want to see the detail. And the effect is really subtle, but I think it's a good effect. So I'm going to decrease the opacity, but so you can see it in YouTube, the opacity is a little bit higher. This is after, and this is before. After and before. So yeah, again, I think this is a little bit too strong. Bring it down a tad. And then I also want to blur the mask so things blend in a little bit better. So let's go to Filters, Blur, Gaussian Blur. And I'm just going to crank this up to about 20, click OK, and there we go. Now if we blink in and out, you can see that the core of the galaxy pops a little bit more. I kind of like the effect. If you want to make the galaxy a little bit brighter, this is personal preference, you could take, again, the luminous layer, duplicate it. I'm going to hide this high pass filter, and I'm going to change this duplicated layer. We're going to call this the screen layer. We're just going to make the layer mode screen. And it just brightens everything up a little bit. It also brightens up the background. So we could also take the levels, decrease it a little bit. Again, personal preference. If I use a screen, then I'm only going to turn the opacity way down so it doesn't load out things. It kind of makes the galaxy pop a little bit more too. If you want to the screen layer, you can add another layer mask and then paint in the screen part of the image again. So just sort of paint this in. And that way the stars don't get too bright either. Now, if I do this, I'm really going to blur the heck out of this so it makes sure it blends in the galaxy to the background. So I'm going to go ahead and Filters, Blur, Gaussian Blur, move this slider up quite a bit. So we get a nice smooth transition from the background to the galaxy. The screen isn't as noticeable. So if we blink in and blink out, it's kind of subtle. Let's go ahead and do the color. Let's add the color to the image. Without the RGB stretched selected, I'm going to go ahead and right click and select New from Visible. Now we have a visible luminance layer, which looks decent. We have the RGB layer, which looks okay. Make it visible again and change the mode from normal to LCH color. And then that adds sort of the color to the image. So there's not a lot of color in the galaxy, which is okay. We do have the color of the relay shining through, which is nice. Everything now, I think, is just personal preference. If you want to, you can increase the saturation by going to Color Saturation and increasing it that way, which is okay. I think there's a little bit too much green in the galaxy based on just for my taste. So I can go to Colors and then Curves. And then we can go to green, just the green channel, and control and click somewhere on the galaxy and just bring this down a little bit. And that works. That's nice. All right. I think when we do this, number one, there's a lot of color noise in here. So if we zoom in, we can see that there's a lot of color noise in the background. The RGB image doesn't have to be sharp at all. So we can go to Filters, Blur, Gaussian Blur, and just apply a little bit of a Gaussian blur to get rid of that noise. And already it looks a lot better, and we're not sacrificing really any of the detail of the image. But there is still a lot of color in the background. And so again, we can use a layer mask and right-click on the RGB stretched, go to Add Layer Mask, make sure it's black or full transparency, click Add. And then we can take this luminance layer. Let's make all these other layers invisible. Go ahead and duplicate it. Let's go to colors and threshold. And what we want to do is make just a black and white image where all the stars are white, all the galaxy is white, and everything else is black. And we can control where this threshold is with this slider here. Move it to the left to make the dimmer parts also white, or move it to the right to make the dimmer parts black, and be a little bit liberal with what I say is white, just so I make sure we're not losing too much color. And you can see that anywhere there is white is going to be where there is color. Anywhere there is black, there is going to be no color. And we can click OK. I'm going to copy this, Control C, layer mask, not the layer, but the layer mask. And I'm going to click Control V, and I'm going to right click on this floating layer and say anchor floating layer or mask. So I'm going to go and anchor that. This is going to make sure that the color only shows up in the galaxy and the stars. Now, nothing else is selected except for this luminance copy. So I'm going to go and delete this. And then I'm going to add all of these layers back in. And now if we zoom in, we've gotten rid of all of that color noise. Now you can keep modifying the color layer without having to or getting kind of weird color gradients in it. And then Gimp has a lot of different tools that can manipulate colors, like color balance here. So if we want to just change the highlights, we can make the highlights a little bit more green and a little bit less red. Same thing with the midtones. Maybe we want to make it a little less red. Being very careful, like less is more in this case, making sure that we're not changing the colors too much. You can put it on split view to see how you're changing things. Again, this is personal preference. You can do the same thing with going to colors and curves if you want to. Again, playing with different values. If you think there's a little bit too much red in the image, you can just slightly bring that down. If you think there's not enough green in the image, you can bring that up. So if you think that this star should be more yellow, but it's too red, you can kind of bring that up. All this is personal preference. If you think that there's too many halos here, like what we might want to do is take this layer mask that we made and blur that a little bit too. So filters, blur, Gaussian blur, zoom in on this star, for example, and blur this until there's a nice transition from the star to the background. I think that looks okay, especially considering we haven't used any AI. We haven't removed the stars to make sure that the stars don't get bloated. And so the last thing we want to do is crop the image, crop to selection. And now, if you want to, you can actually get rid of this field curvature. There's a little bit of field curvature, as you can see in the corners. We do have a field flattener, but it's not perfect. There's a little bit of field curvature. So a quick and dirty way to do that is to go to filters and then lens distortion. This main slider here can correct for the field curvature. So let me go ahead and make a new image from visible. I'm going to deselect all of these, and I'm going to go to filters again, lens distortion, and adjust this slider, move it to the right a little bit, and then check the star, see when they kind of get more circular. Yeah, I think that looks okay. Again, you don't have to do this. It's just sort of personal preference. I'm going to go ahead and click OK, and then I'm going to do R, press R on my keyboard again, rectangle select this part of the image, go to image and crop to selection. And there we go. We should have a fairly flat image that's correct for the curve of the stars. All right, I think that's it for this tutorial. Here's the final image from the tutorial. I also made another version that I like a lot better. And this one also didn't use any artificial intelligence tools. Which one do you like better? If you enjoyed this video and would like to see more content like this, consider subscribing and check out No AI Challenge, which was the inspiration for this video. Thanks for watching.